Hello everyone, welcome to Augmented Technology Private Limited. Today I am excited to introduce our one of the product, that is 4DIM. It's an 4-channel digital input communicating with the Modbus, that is RS485. Here we have the base model. Here we have the power supply part. We have the provision as the positive and negative, where you can provide up to 24 volt DC. Here we have the RS485. For this RS485, we have the configuration as the A for the positive, B for the negative, where you can connect with the RS485 cable to the PC to get the data. Here we have the dip switch part. In this dip switch, where user can set their own slave ID and the baud rates. For the baud rates, we have already mentioned in the board. And for the slave ID, where user can set up to 15 slave ID. And here we have the reset part. Whenever we are changing the baud rate and the slave ID, on that time we need to press the reset, so the board will get configured with the new slave ID and the baud rates. And here we have the 4DI part, which is operated through the optocouplers, which support up to 80 volt. For the next step, we will focus on the testing process. Please consider on the testing procedure. Ignore the board visuals which is provided in the video. In this video, we will only know about how to connect the power supply and how to connect the RS485 with the Modbus cable. Okay, here we have the power supply part. There we have mentioned in the board, that is positive and negative. Connect the power supply with the positive and the negative and provide the power supply. See here the LED turn on, that means power supply has provided properly. Then get to know how to connect the RS485 cable. Here we have provided the configuration as the B, that is for negative. Here I have connected the negative. A for the positive, I have connected the positive wire. So then connect this wire with the PC. Okay, this is the RS485 cable. So I am connecting this with the PC. Now we will connect the RS485 cable with the PC. So I have connected with the PC. Now open the device manager. In the device manager, go to the port here, that is showing as the COM6. That means I am using the port number 6 for the serial communication. So then go to the Modbus pole, click on connection, connect the board and select the port and click on OK. See, the board has connected properly. After proper connections, here you will get the RX and TX LED blinking continuously. That means RS485 communicating with the PC properly. In this video part, we will get to know how to configure the slave IDs and the baud rates. So here we have the slave ID and the baud rates. So by default, that is the 9600 baud rate and the slave ID will be a 1. So now we will go with the PC. See here the board has connected properly with the default baud rate and the slave IDs. So now I need to change the slave ID as the 3. Okay, before changing the slave IDs, here this is the dip switch for the slave ID. So here in the dip switch they have mentioned 1, 2, 3, 4. That means the slave ID configuration as the 1, 2, 4, 8. That means if I need the slave ID 3, then I need to hide first and the second pin. That means 1 plus 2, that will be a 3 slave IDs. Okay, then I need the baud rate as the 19200. So the first pin that is mentioned in the board, that is 19200. So I will hide this pin. Now I need to press the reset. So the board will get for the new configuration. See here I will get the timeout error. Whenever you will get the timeout error, disconnect the board and connect the board with the new configuration. The baud rate as 19200 and the slave ID will be a 3. Okay, see, after connecting this, here the TX has continuous increasing. That means the board has connected with the new slave ID and the baud rate. So now I need to set the slave ID as the 5 and the baud rate will be a 38400. So now I will hide the first pin slave ID and the third pin slave ID. That means 4 plus 1 that will be a 5. Now I will need to set the baud rate, that is 38400, that is the second pin. So I will hide this pin and now I will press the reset. See, here I will get the timeout error. Do the same thing, disconnect the board and connect the board with the new configuration. The baud rate will be a 38400. Okay, then the slave ID will be a 5. See, here the board has connected properly with the new configurations as a slave ID 5 and the baud rate 38400. So now I need to set the baud rate as the 57600 and the slave ID will be a 15. So if I need the slave ID as the 15, then I need to hide the all slave ID pins, that will be a 15. Okay, now I need to set the baud rate, that is for the 57600. Okay, now I need to press the reset button. Here I will get the timeout error. Then disconnect the board and connect the board with the new baud rate and the slave ID. Here the baud rate 57600 and the slave ID will be a 15. See, the board has connected properly with the new slave ID and the baud rate. Now I need to set the slave ID as the same and the new baud rate, that is 15200. See, okay, 15200, that is the new baud rate. Just press the reset, disconnect the board and connect the board with the new baud rate, that is 15200. Click OK. See, the board has connected properly because I have put the slave ID 15 as same and the only change, that is baud rate. Now I need to get back all these with the default. So load the all pins. Okay, otherwise you can set only first pin as a high for the slave ID, otherwise you can low, there is no issue. Now press the reset. The board has gone for the default slave ID and the baud rate. So now here I will get the timeout error. Disconnect the board and connect the board with the default address. Baud rate is a 9600 and the slave ID will be a 1. See, the board is communicating with the properly for the default addresses. Now open the Modbus, go to the connection, connect the board with the port ID and click on OK. See, the board is connected properly. That means here you are getting the RX and TX blinking continuously. That means the RS485 connected properly with the PC. And according to the datasheet, there mentioned the DI registers. Okay, on that mentioned registers you will get the DI values. For the DI we need to take the reference voltage. Here I am taking the reference voltage, that is 12 volt, which is provided in the board, that also mentioned in the DI part. And here I have taken the male to male jumper. Okay, this is the male to male jumper. For the DI reference I have connected with the 12 voltage. This is the 12 voltage reference. So whenever I will short with the DI1, here the LED also turn on for the DI1, and also in Modbus pole I will get the mentioned register value as the high. For the particular register I will get the value as the high, that is 1. I will do with the short with the DI2. See, here also you will get the LED on for the DI2, and also in Modbus for the particular register you will get the value as the 1, that is DI2. And for the DI3 I will do the same. See, here also you will get the LED on. That means in register also you will get the high value 1. For do with the DI4 also, here also the DI4 LED turn on, and also in Modbus pole you will get the value as the high 1. Don't do with the ground, only short with the DI parts except the ground part.